Kinetics is the study of rates of chemical processes and investigates the different conditions that influence the speed of a reaction.
Temperature has a big effect on the rate of a reaction. At higher temperature, the molecules move faster and have more collisions. If the temperature is low, this would cause the molecules to move slower and have less collisions.
Thermochromism is the property of substances that change due to the change in temperature. An example would be a mood ring. When you put it on a finger, it should change color due to the temperature of your finger. Usually people think it changes because of your mood, because it's called a mood ring.
The change in the rings are due to the liquid crystals in them. The crystals change color as the temperature changes. We know temperature is a measure of the average kinetic energy, which also means the average molecular motion. The changes in the molecular motion happen because the temperature change results in molecular shapes that reflect different amounts of visual light energy.
In this lab, we use thermochromic pigment, which has a dye called leukodye, which can switch between two chemical forms. It changes colors and one which is colorless. After absorbing a certain amount of light or heat, the molecular structure of the pigment reversibly changes in a way that absorbs and emits light at a different wavelength than at a lower temperature. This change happens because the hotter objects emitting a shorter wavelength than colder objects do.
Since we knew the wavelength of our slime, this helped us calculate frequency and energy. We used equations like lambda equals c divided by nu and E is equal to h times nu. In the lambda equals c divided by nu equation, c is equal to speed of light, which is the constant, 3 times 10 to the 8th meters per second. Nu is equal to frequency in seconds, and lambda is equal to the wavelength in meters. In the E equals h times nu equation, E is equal to energy, which is in joules. H is Planck's constant, 6.626 times 10 to the negative 34 joules per second, and again, nu is frequency in seconds. Since our slime was purplish at room temperature, and purple light is visible at 380 nanometers, we used the nanometers to help us find the amount of energy. So in order to find the amount of energy, we first had to use this equation to calculate for frequency, and then we'll enter that in the E equals h times nu equation. So in this equation, we are solving for frequency because we already have the wavelength, which is 380 nanometers, and we already know that c is the speed of light constant, 3 times 10 to the 8th. When we solved for frequency, we ended up getting 7.9 times 10 to the 14th. We were then able to use that frequency, 7.9 times 10 to the 14th, and plug it into this equation. We know that h is Planck's constant, 6.626 times 10 to the negative 34, and we multiplied that by our frequency, which is 7.9 times 10 to the 14th, and then we got our energy. We calculated our energy to be 5.2 times 10 to the negative 19 joules.
Like the most excited person in all Europe. Okay, should I stop it?
You don't need to follow me around. I'm actually coming.
Ooh, this is not the right consistency, I think.
I threw it in.
do not think this is the right consistency, Jay.
Push it in.
Leo, 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 Leo.